Hey folks, welcome to the session. We're going to be talking about DevOps with Visual FoxPro. And before I get into it, just a little bit about me. This is my third time speaking at Virtual Fox Fest. I'm the project manager for several projects on VFPX and GitHub. That list might be getting a little longer today. Check out my blog at joelleach.net. If you're curious what some of these instruments behind me sound like, check out my YouTube channel. You'll see that I made the right choice going into programming. And oh yeah, there are a few FoxPro videos out there as well. Besides that, I'm like most of you. I've been doing software development with FoxPro and its predecessors for a very long time. That's expanded over the years to SQL Server, .NET, Angular, TypeScript, and other things. And I've been at my current employer, MBS, for 22 years and counting. Okay, on our agenda, let me start by saying that DevOps is a huge subject, right? And one of the reasons I chose this topic is so that I could expand what I already knew about it, and more specifically, how to apply these techniques to VFP. But I'm by no means an expert. So we're going to start by defining DevOps, looking at it from a high level. Then we're going to discuss continuous integration and build a CI/CD pipeline for FoxPro. Not sure what that means? Well, you'll find out. Lastly, we're going to discuss this concept called infrastructure as code, and we'll spend most of that time talking about containers. Now, what is DevOps? If you've ever watched a Microsoft keynote session at one of their conferences, you might have noticed that Microsoft has this habit of throwing new terminology out there as if everyone in the audience already knows exactly what it is. And I think it was at the Build conference in 2016 that the new word, at least for me, was DevOps. They told me to rub some DevOps on it. And naturally, I wanted to know, hey, what is this DevOps of which you speak, and what will I be rubbing it on? And this time, Microsoft actually went on to define it by saying that DevOps is the union of people, process, and technology to continually provide value to customers. Doesn't that make you just feel warm and fuzzy inside? Maybe so. I'm pretty sure they would have thrown world peace in there if they could have. But does it tell you anything about what DevOps is? Well, not to me. So how about we take a different approach? And as is often the case with a popular buzzword, there isn't just one definition of DevOps out there, right? And this session, of course, is going to be my interpretation of what DevOps is, but I think we'll be in the same ballpark as others. So let's start from just the very basic. The dev in DevOps refers to development, writing code, the stuff that you and I do every day. Ops refers to operations, IT stuff, setting up and maintaining computers, desktop computers or laptops, configuring servers, running networks. Basically everything that Rick Schumer hates, right? But it also includes installing applications, which is an important point when you're talking about DevOps. Let's also talk about some of the activities that are included in DevOps, things that many of you have probably already done. Things like working with source control, writing automated tests, whether we're talking about unit tests, integration tests, whatever. Building a software application or an executable. Creating installation packages for your application using tools like Setup, Install Shield, and others. Then actually deploying those packages, installing them on machines. Now, if you're doing some of the more advanced things like automated builds or continuous integration, well, you're firmly in DevOps territory. And you might be thinking, we've been performing a lot of these activities for decades now, right? And we've even been talking about some of these more automated topics for a while now too. Does this mean we've been doing DevOps all along and it's just a new name for it? Not really. DevOps is about pulling together and automating all of these things, okay? And we're going to talk about this in more detail later, but let's just take a brief look at continuous integration, a key component of DevOps. It's going to give you a little bit more idea of what we're talking about. So the typical flow with continuous integration is that a developer makes a change to some code, then they commit that change to source control and push it to their central source control server. This triggers an automated build of the software. If that build fails for some reason, the process stops and a failure notification is sent back to the developers. Okay, if it succeeds, we move on to the next step, which is to run all of the automated tests. Again, if a test fails, the build process stops and a failure notification is sent back to the developers. If all goes well, we have a successful and completed build, and we'll talk more about where to go from there later. Now, all of these things I've listed, they're primarily non-coding activities, right? So does that mean that DevOps refers to operations or IT stuff for developers? Well, that isn't really it either, right? As we mentioned earlier, Dev and Ops are separate sets of responsibilities, okay? And they're often separate teams and companies. You know, the ones that point fingers at each other when something goes wrong. And where do these two groups, these two sets of responsibilities intersect? Well, it's at the deployment of an application that's being developed. There's often this wall between the two, right? Ops isn't about to let Dev touch one of their production servers. So devs have to schedule the deployment with IT. Maybe they need to get authorization to do that. It can add up to a bunch of red tape that wastes time and slows down deployment. Well, DevOps really centers around deployment and making that activity less painful. Okay? Automation, including things like continuous integration, is used to make the process more predictable, more reliable, and just raise confidence on both sides. This does require members of Dev and Ops to work together on the same team. Now, it doesn't necessarily mean you change the corporate structure and erase the division entirely, okay? So writing code, that's still a pure dev activity. Setting up laptops, running networks, those are still ops activities. But when you think about the context of an application, there's one DevOps team that's responsible for everything that an application needs to function from end to end. So in that sense, it is breaking down this wall between Dev and Ops and bringing them together. It's not world peace, but it does reduce friction between the departments. While learning about this stuff, I ran across this article that asked, is DevOps replacing Agile as the dominant software development methodology in the industry? And my first thought was, wait a second, is DevOps a methodology, or is it just adding automation to the mix? Well, the answer is yes, it is a methodology. Now, I don't see it as a replacement for Agile, at least not in the same sense that Agile has replaced Waterfall. But one of the major goals of Agile, or tenets of it, is frequent releases to get feedback from users early and often and to improve the product. And that goal in particular exposed this barrier, this bottleneck between Dev and Ops, and put pressure on that situation. And DevOps addresses this by shifting the focus to deployment. And that can require a different mindset, maybe even a cultural change within some companies. And nothing exists in a vacuum, right? So that ultimately affects everything. Now, let me know a little more. Let's state the key components of DevOps. And we already talked about continuous integration, and that encompasses some other things such as source control, automated tests, automated builds, and deployments. Another key component is infrastructure as code, which we're going to talk about later. Ongoing monitoring. Now, The team doesn't disband when version 1.0 of an app is delivered. Say it's the first feature complete version. Maybe the team makeup changes, maybe the size is reduced, but the team itself, and more importantly, the DevOps process continues for the life of the application, right? And so ongoing monitoring has this same theme of automation where let's let computers do the monitoring rather than a human being, right? And so there are various tools of monitoring that are available to help improve the product. Communication and collaboration already also come into play. Things like bug tracking, Kanban boards like Trello, team chat systems like Slack or Microsoft Teams, dev documentation like in a wiki or SharePoint, things a lot of us already do, right? But are critical to the success to a successful DevOps implementation. What about microservices? Are they a part of DevOps? Well, it depends on who you ask, but my take is that microservices are not a requirement of DevOps, but they are a motivator for using DevOps. So you can absolutely adopt DevOps without adopting a microservices architecture, and you're going to get benefits from that. But take the inverse situation. If you do adopt microservices, you're probably going to want to use DevOps. And so if you think about microservice architecture, that's about dividing an app into multiple smaller self-contained pieces from the code all the way down to the database. And you generally wrap that with a web API or some other means for accessing the service. So let's say you divide an app into a dozen microservices, right? And then the teams are each wanting to deploy changes for their service independently and frequently. Well, traditional deployment practices, they're just not going to hold up, right? The ops couldn't handle that load. So automation is needed to make microservices feasible. And as a result, you do see microservices and the DevOps movements sort of coinciding, but I still consider them separate things. Microservices are often deployed using containers as well, which, as I mentioned, we're going to talk about that later. By now, you might have ascertained that someone's going to have to set up and maintain all of this automation stuff, right? Every developer on your team, they're going to need to know how to use source control, of course, and write automated tests. But you're right. There is a new role that has emerged to support these systems. Enter the DevOps engineer. You probably already know the person on your team who would fill this role because it might be you. Or it could be another dev on your team that they have some IT skills and is probably already handling some of these responsibilities. Or it could even be an ops person, right? That knows a little bit about development. They know how to set up source control, or they're really good with PowerShell. The point is, if you're going to adopt DevOps, you do need to have some personnel assigned to support the process in tools. So once you get a handle on what DevOps actually is, you're going to find that some folks have added a syllable, DevSecOps. Now, I had to leave this section on the cutting room floor, but check the white paper and learn more about incorporating security into the DevOps process. Okay, so that's my definition of DevOps. We're going to talk about continuous integration next. Let me just check in and see if there are any questions so far.
No questions so far.
Okay. Okay, so we've already seen the basic continuous integration process, right? Push a change in source control, that triggers an automated build, triggers automated test. There are other things you could insert here. Got coding standards. You could use code analysis to report divergence from those standards during the build, right? Now, Andrews McNeil's code analyst, that seems like it'd be a good place to start. Now, I didn't do any testing with it. I'm not sure it would work in this type of environment, but that would be something to check out. You could even change code as part of the build, right? Get rid of all those ugly M dots. Replace all those space indentions with tabs as God intended. Convert all your GIFs to GIFs. If you can script it, it can be done. Okay. Now, once you have a successful build, continuous integration is basically complete. If that doesn't sound like the job is quite done, well, you'd be right. Okay. And I've been using continuous integration as sort of a catch-all term for this section, but you typically follow it up with continuous delivery, which is automating the creation of a deployment package. That's, in other words, a package that can be used to install your application. So this is where you would use NO setup or some other packaging technology, or maybe just Xcopy or zip file would meet your needs. This might also be a stage where you run tools like Refox to encrypt your code, or embed a signed certificate into your executable. And I know some folks have been having fun with that on Twitter. So for a lot of this, that's where the story ends, right? The installation package is sent out, deployment is left to the users or the IT department, and we hope that they can install the package successfully. When something does go wrong, they contact us. We often wish we had more control over the process. Well, there is another stage that's part of DevOps called continuous deployment, and that may be available to you depending on the situation. This is automating the deployment of that package on one or more machines. Now, let me assuage your fears. This does not mean that every commit into source control is going to be released directly to users in production. Okay, automating testing doesn't negate the need for QA, for release planning, or for marketing efforts around a release. In my mind, there's still a manual step involved before production releases. That might be clicking a button to deploy the release. It might be merging features to a certain branch in source control. There are some teams that actually do deploy every commit to production, but they're very deliberate about it. So they'll use feature flags to enable new features whenever they're ready to release them. So at that point, turning on those features, that then becomes the manual step for a release. Okay. So yeah, there usually is some manual intervention there. But that said, automated deployments can be made for your internal testing and staging servers for every commit. Those can happen automatically and get changes out to your testers and internal users quickly. Most important part of continuous deployment is that the release process itself is automated. Okay, so by now I've said automate like probably a bajillion times, right? So by that, I primarily mean scripting, putting together script or code or configuration file that's going to automate a process you might have otherwise done manually. So besides, you do get a benefit, obviously, from automating the process. There's an added benefit that the script can serve as documentation for your build and your deployment processes. So someone else could come along and now much more easily perform the process rather than relying on some outdated document, and it's always outdated, isn't it? Or worse, steps that are only in your head. Now, continuous integration and delivery are typically handled together in the same CI/CD pipeline. We're going to be using Azure DevOps to demonstrate this pipeline. Okay, what is Azure DevOps? Well, Azure DevOps is a service from Microsoft, formerly known as Visual Studio Team Services, formerly known as Visual Studio Online, not to be confused with a different service that was named Visual Studio Online before it was renamed to Visual Studio Codespaces and then merged with GitHub Codespaces. But I digress. Visual Studio Online was the online version of Team Foundation Server. Obviously not. In a belated display of branding consistency, TFS has been renamed Azure DevOps Server in spite of being a completely on-premises product. And TFS was Microsoft's replacement for Visual SourceSafe, which I actually still use on some projects. It's worth mentioning that Azure DevOps in no way requires you to use Azure for your cloud or hosting needs. You can use it with pretty much any cloud service and even your own on-premises servers. And word on the street is that Azure DevOps will eventually merge with GitHub Enterprise, although if that actually does happen, that's going to be years away from now. So you got all that? Good old Microsoft branding. Why don't we try this again? What is Azure DevOps? And I'll just list a few of its features. It provides repositories for source control, pipelines for continuous integration and delivery, and releases for continuous deployment. Now, those are the things we care about for this session, but there is a slew of other features that you may or may not be interested in. In any case, I'm not promoting Azure DevOps over other solutions. It's just what I use, and I'm primarily demonstrating concepts, and what you see should work somewhat similarly in other tools. There are a ton of other options out there, so check those out and decide what is best for you. Okay, it's been a whole lot of talk, whole lot of slides. Let's actually build a pipeline. So I'm going to move over to my browser. And I'm going to go into the pipelines section of Azure DevOps. And I'm going to click on New Pipeline. And Microsoft considers a YAML file the modern approach for creating a pipeline. But I'm going to use this classic editor option down here because I didn't want to learn yet another markup language, and because it's what I've been using for years, and I think it's better for demos, but of course follow your own preference in this regard. So I'm going to click on Use Classic Editor, and you can see it supports multiple source control services. Your repository doesn't have to reside within Azure DevOps, and including your own on-premises Git repositories. Now, I am going to choose a repository right here on Azure DevOps, and this contains a sample Northwind app I put together for my .NET to Fox session last year, and I've just tweaked it a little bit. So I'm going to press Continue. And Microsoft makes several templates available for pipelines that are available for various development tools. But as you might have guessed, there's not one for FoxPro. So you would just choose the empty job up here. And in this pipeline section, you would configure an agent pool. Now, this is where the build is going to be performed. So as part of Azure DevOps, Microsoft makes a hosted VM. These are pre-configured virtual machines that you can use to run your build. Or if you prefer, you could use your own private build server and configure that in this area. I'm going to use the hosted VM. And when you make that selection, you also have to choose which operating system that's going to be based on. And the rest of the steps, you would add tasks in this agent job section. So if I click on the plus sign, again, Microsoft makes templates available for each task at this task level now. And again, there are none for FoxPro. So at this point, I'm going to switch over to my pre-cooked build pipeline and edit that. Now, these hosted VM that Microsoft provide, they do have certain tools pre-installed, like for various build environments like .NET, Node.js, Python, and others, right? Most tools that you could use to perform a build. Of course, FoxPro is not on that list, so our first step is going to be to install it onto the VM before we can perform a build. I use the Woody installation process for this, which basically says make a copy of your existing VFP folder that's already on your local machine, and then install the VFP runtime with it to handle all of the other dependencies or DLLs that FoxPro needs. So in this case, I'm actually going to install the runtime first. That works out better in this situation. And so my first step is to download that, and I'm downloading it directly from GitHub, where the runtimes are hosted as part of the VFPX project. And so I'm downloading this file and putting it into the C drive install folder. The next step is then to just simply run that installer in silent mode. Now, it's important that the user doesn't get prompted for anything, right? For any information during the build. They won't see it, they won't be able to respond to it, and so the build will just get stuck. Okay, so I've got the runtime installed, but I don't have a publicly accessible download for VFP. So I created my own package, and I'll show you that. If I go here into this folder, and here's my Microsoft Visual FoxPro folder, and it probably looks very much like yours, right? Except I have added this config fpw file, and it really has just one important line here, which is to turn off the startup program. This prevents the task pane from opening up like it always does for new installs, right? And if you're like me, anytime after a new install, your first task is to go turn that off, right? But more importantly, that's another thing that will kill your build. So this needs to be included. And my package also includes a batch file to install that. And it's just very simple, right? Move my files, FoxPro files, into program files, which is the default location. Or you can put it somewhere else if you want. And then to register VFP9. Okay, so that will install VFP. Actually, no, there's one more step. To make this package available to my build pipeline in Azure DevOps, I have to first publish it as an artifact into Azure DevOps. So I'm going to open this artifact section. And you can think of an artifact as just a zip file containing your package. So there we go. As you can see, I've already published my VFP9 package into Azure DevOps. And that makes it available here. So I'm going to download that package, and this is where you would set the package to download. And I'm going to download it into the C install folder. Again, this is on the hosted VM. Then once that's downloaded, then we simply run that batch file to install VFP onto the VM. Okay, now I've finally got VFP installed. I'm ready to actually perform the build. And this step simply calls a batch file named build northwind cmd. Now this batch file is contained within a build folder, and this entire build folder is it's part of source control. So that's how these files, any files within this folder, are going to get to the hosted server whenever it's pulled down from source control. Okay, so here you can see within this batch file, we're starting VFP, and we're telling it to run build northwind PRG, which is where our build is actually going to be performed. Before we look at that code, I want to point out one thing. Normally, when you run a Windows GUI program from a Windows command prompt, it will return control back to the command prompt immediately, right? It doesn't wait for that GUI to close. And that would cause a problem for us because we want to run this build and then wait for it to complete before we proceed with the rest of the batch file. Okay, so Microsoft made an exception for batch files like this CMD file, which is that when it is run from a batch file, Windows will wait for the GUI program to close before proceeding. That's good. That's what we want, right? But it also means that VFP needs to quit in order to return control back to the batch program. We're going to show that in a minute. Now, this behavior is unique to batch files. I'm pretty sure, like, if you use PowerShell, you're going to have to explicitly tell it to wait for VFP to close. And there's a link here that will help you with that. Okay, so let's look at the PRG file, and I'll just keep this in Visual Studio Code. So that these first few lines, I'm just trying to prevent any dialogue from popping up, right? So if one does pop up, you won't be able to see or respond to it. The build's going to get stuck, okay? So I put every command I could think of up here to prevent that from happening, but obviously if I forgot something, it would need to be added to this program. Then here's the major line of code that actually performs the build. If any unexpected error occurs during the build, those will be written to build error log. Something like, for some reason, Northwind PGX is not actually there, right? That's going to cause an error, and then that would be written to the log. In addition, any compilation errors within the project, well, those are going to write that Northwind ERR file as usual. Finally, we have that important quit command here so that we can return control back to the batch file. So I'm going to go back now. And here we're checking to see, okay, does build error log exist? If it does, display that there was an error. Then display the contents of the log file. Now, anything we display here in the command console is also going to appear in the Azure DevOps logs. So if we do have a failure, we can go to the Azure DevOps logs later and see exactly what caused the error. And then we're also setting this build error level variable to 1, and I'll explain that in a minute. And we're doing the same kind of check for compilation errors. If this Northwind ERR exists, then yeah, display the contents of that error and set the build error level to 1. Then we just do one final check here to make sure Northwind EXE actually exists after the build. Then here at the bottom, we check that build error level. If the value is 0, we have a successful build. There were no problems. But if it's not equal to 0, then what we're going to do is return that variable to Windows. And that tells Windows, hey, an error occurred during the batch file. That in turn reports to Azure DevOps that the build failed. Azure DevOps is going to cancel any remaining steps in the pipeline and send out a failure notification by email. Okay, so let's go back to the pipeline. At this point, our build is complete, and we're ready to run some automated tests. So I'm going to first download FoxUnit, and again, I'm doing that from GitHub. I did encounter a bug while running FoxUnit in continuous integration mode, and I fixed the bug. And I don't know if that's made its way into an official FoxUnit release yet. So if you're going to do this, make sure you have the latest code, or you could also just download it from my fork of FoxUnit here. And then we just install FoxUnit by unzipping that file, right? And that's going to put it in the C drive FoxUnit folder. Once we have that installed, we're ready to run the test. And again, it's very similar to running a build. So it's going to call a batch file that is still in our build folder here. And inside that batch file, we're going to start VFP9 and tell it to run the run tests PRG. And there is a little bit of setup code here, but the main line is right here. Start FoxUnit and pass this parameter. which tells it to run in continuous integration mode, which basically means detect and run all of the tests that are within source control. Then that's going to return us back to our batch file. We report the results of the testing, display any logs, and if there are any errors, again, we notify Azure DevOps about those errors. And if there are any, that it's going to cancel the remaining steps in the pipeline and send out a failure notification. Okay, if all tests passed, we have a successful build. Continuous integration is complete. Okay, and then we're ready to move into continuous delivery. So for that, I've put together an inno setup script. And to use that script, we actually have to install inno setup onto the hosted VM. It wasn't something that was included automatically, but there is a template on Azure DevOps for this task, so it was really easy to do. So I've installed it, and then I'm telling it to build our package based on the Northwind inno setup script, which again is a part of our build folder that's in source control. And once that is complete, this will produce a setup package, but we need to get that off of the hosted VM. Okay, once a build is complete, a pipeline is complete, Microsoft wipes that VM clean and returns it to the pool. Okay, so we need to now get our installation package somewhere else in Azure DevOps so it'll be available to use later. And so to do that, we first copy any files, and there's our Northwind setup exe, into a build artifact staging directory. Okay, and that could contain many other files if it needed to. And once files are in that directory, then we publish an artifact from that directory into Azure Pipelines. And by default, the name of the artifact is just drop. Okay, so our CI/CD pipeline is now complete. There is one more option to set. If I click up here on triggers, there's an option here to enable continuous integration. And with that checked, this build is going to run automatically each time a change is pushed to source control. You could also run the build manually at any time with a single click. Okay, so we've got continuous integration. We've got continuous delivery. How about continuous deployment? For that, we need to hop over to this releases section, and we'll take a look at our Northwind deployment. Here in this artifact section, this is where you choose which build you're going to be deploying. You might have multiple build pipelines, and this is where you would choose that. And of course, we're deploying the Northwind build. Here in the Lightning Bolt, this is where you can set or enable continuous deployment, meaning anytime we have a successful build, automatically run this deployment and install it to our internal testing or staging server, right? If I go over to the tasks here, this deployment group job, this is where you would set which machine you want to deploy the build to. And I have set up a server named VFF for that purpose. Of course, some configuration is required so that Azure DevOps can communicate with your server. And that's done in this deployment groups section, and I'll open that in a new tab. And you can see here's my VFF server. And if I look at the details, Microsoft provides a script for you to do the installation. So I would just come to this page, click Use a Personal Access Token, copy this script to the clipboard. Then I would go over to my target server, open up PowerShell command prompt as administrator, paste this in, run it. That's all that's needed, right? It's going to install an agent on that server. It's going to register that server with Azure DevOps. Now you can perform deployments on that server. It's really easy. And here's where I've chosen that deployment group, VFF. And if I scroll down a little bit, you can also see this is the artifact. If I drill into that, there's my Northwind setup that I want to install. So then the installation becomes very easy. I just need to run Northwind setup again in silent mode. Okay, so that's everything. What do you say? Shall we run through the pipeline, see it in action? Before I do that, let me just show you. I do have my Northwind app previously installed on my VFF server. And I'm going to open up this customers form. And this label here, we're going to change that. Just a very simple change so to make the, to kick off the pipeline. Okay. So I'm going to close this and go over to VFP. And here's my Northwind project. I'm going to open up the customers form. And I'm just going to change this caption. Okay, that's weird. Okay, so we've made our change. And normally I would right click and use click commit all. I'm using Doug Hennick's Project Explorer, which makes integration with Git very easy. But for some reason, I've got some kind of configuration problem messed up on here. And it only happens when the camera's rolling. So I'm not going to tempt fate here. Instead of pressing commit all, I'm going to, did I already lock it up? Let's try this. Okay, I'm going to convert binary to text on my customers form. Then I'm going to come back to File Explorer, right click, and then do my commit from here. And again, this is just a problem on my machine. And I'm just going to say VFF rocks, and I'm going to commit that change. Now at this point, the commit is just on my computer. We have not kicked off a build yet. And I can do as many local commits as I want before I push to the central server. But once I push, and I'll do that now, okay, this is going up to the central server source control repository in Azure DevOps, and that should now have kicked off my build, my pipeline. So I'm going to come over here to pipelines, and here I can see it's been queued up. I'll go into the logs, and this should start any second now. Any second now. There we go. Okay, and the first step is just Microsoft is initializing the VM. Okay, then it pulls down our source code from Git. And this might, yeah, it's running a little bit slower than usual. And again, this is a VM hosted by Microsoft that this is running on. The next step is to download the runtime from GitHub. Let me refresh. Sometimes that's okay. And then we install that in silent mode. And now it's moving on to the next step, downloading our package, our artifact package onto the VM. And this is a little bit larger package, and so it takes a little bit longer to download. Although it is hosted on Azure DevOps, and this agent, this VM is hosted on Azure DevOps. I would hope it'd be a little bit faster than this, but sometimes it takes a minute. Then it ran our script to install VFP9. Now we're finally performing the build. And we can see that the build has completed successfully with no errors. Next, it downloaded Fox Unit, installed Fox Unit, ran the Fox Unit test, and where we get statistics that I only have one test in here, one of those, and it ran successfully, 0 failures. Now it is installing Setup onto the VM. Sometimes you have to refresh. And sometimes it's just slow. Okay. Sorry, this step doesn't usually take this long. I think a whole lot of folks are doing builds right now. Okay, so that's installed, and now we've built building using our Northwind Setup script. Okay, and once that's complete, we copy that Northwind setup into that build artifact staging directory. Finally, we publish that artifact back into the that area in Azure DevOps, and the rest of these steps are just Microsoft cleanup for the VM. Now we go over to releases, and we can see that it is now automatically running because we had that continuous deployment flag enabled. And that's usually pretty quick. And here, this step, I'm sorry, you can't see the text very well, but first step is just download that artifact and then run that Northwind setup in silent mode. So this is complete. We go over to our Northwind app, open up the customers form. This worked right. Boom. There we go. Our change has been deployed. What do you think? Pretty cool? There is a lot of steps, right? There are a lot of steps in there, but they're automated steps, right? You won't have to do them manually. And it could be done in a clean environment, right? There are hardly any prerequisites to run that. So you're probably wondering what a failure might look like. So I'm going to go back to the build here and look at some past logs. And here, if I look at this log, I had a build failure, right? And so I just added a line of code that I knew would cause a compilation error in one of my programs. And here I get the reason for the failure in my Azure DevOps log. I can see that it did not run the remaining steps except for a little cleanup at the end. Same thing with tests. I come over here. I added something to make a test fail, right? And so it reports that the value they weren't what was expected, right? And so now we have the full reason for the test failure. And again, it canceled the rest of the pipeline. And I got an email about this failure. So I've made this Azure DevOps project I've been showing you to create this pipeline. It is publicly available at this link. Unfortunately, when you go to that link, you're not going to have the full visibility to see the pipeline in detail. Unfortunately, Microsoft put some limits on that. I don't understand why, but there are more details in the white paper, in the examples, and of course, you'll have this video to see it. Okay, so that's it for this section. Do we have any questions?
Just one. Does Azure DevOps require a subscription?
There are free options available. At least there used to be. So I can tell you, if you have a Visual Studio subscription, or formerly known as MSDN, that includes access to Azure DevOps. But I believe there are free options. It used to be for small companies up to 5 developers. You could get the service for free, and it was pretty good. It pretty much gave you everything. Anything else?
That's it.
Okay. Okay, so let's talk about infrastructure as code. And what do we mean by that phrase? Well, infrastructure refers to the system requirements of an application, the stuff that's typically not installed with an app, right? But nevertheless required for an app to run. So things like Windows, like SQL Server, IIS, .NET Framework, whatever. And what about code? Well, that's the same thing we've been talking about already, scripts or configuration files that are used to automate the setup of the infrastructure. And you've kind of seen some of that already, right? For our Northwind build, Microsoft provided some of the infrastructure with their hosted build server. But to run our build, we needed more, right? We needed FoxPro. So I wrote scripts, aka code, to install VFP, to install Fox Unit, and set up the things that we needed to perform the build. So in infrastructure of code as code, it includes things like that, but it even goes to a lower level, like which operating system do you need, and even configuring a configuration for a VM below that operating system. So say your app needs a Windows server with IIS, .NET, and SQL Server installed. Well, you could write code or scripts to install and pre-configure those. Now I have to gloss over these next two slides, but cloud providers like Azure and AWS provide JSON templates for this type of configuration and deployments at this level. There's also a number of third-party tools available in this space you might run across. But we're going to spend the rest of our time talking about containers. So have you ever automated the installation of something like SQL Server or IIS, written a script for that? It works most of the time. But when you're installing into a foreign environment, such as a customer server, really anything can happen, right? Each time a client installs, you sort of hold your breath and hope it works the way it's supposed to. Well, wouldn't it be nice if you could perform the installation and configuration ahead of time in a clean environment and deliver your app to the client knowing it already works? And maybe some of you have done something like this before, especially in the olden days when turnkey hardware and software were a thing. Maybe you ordered a machine from Compaq, you set up Windows on it, or maybe it was even DOS back then, installed your app on it, just brought the whole machine to the client ready to go, right? Well, those were simpler days. The concept isn't really feasible in most of today's environments. If IT would even let you through the door with it, right? You'd have to figure out how to get that machine on the customer's network, on their domain. And then, of course, there are licensing issues to deal with. Well, containers bring that concept back in a way that can work in these existing infrastructures. So what exactly are containers? Well, conceptually, containers are very similar to VMs. And a virtual machine, as the name implies, is virtual hardware. So you would install a complete operating system inside the VM, just like you would directly on the hardware. Containers, on the other hand, they run on top of the kernel of the host operating system. So here you can see I have two containers running on top of the kernel. And this still provides some isolation and protection from other things running on the system, but containers are much more lightweight than VMs. And they, more importantly, are easy to deploy into these existing environments. So containers have become a popular method for implementing infrastructure as code, even in environments that are not foreign, even in environments that they have complete control of. And everything that your application needs can be installed within containers. The only prerequisite is a server running Windows or Linux with the container support enabled. So devs can create these containers with everything that's needed for an app. Ops can configure the containers and not have to worry about corrupting anything else on the server. So everyone's happy. Now, Docker has become almost synonymous with containers. So if you haven't heard of containers, you probably have heard of Docker. How does that factor in? Well, containers are a feature of an operating system, whether you're talking about Windows or Linux. Docker is a separate utility that's more or less become the de facto standard for building and running containers. And here are a few common Docker commands that you'd run across. Docker build. This builds a container image. Any installation and scripts run at build time, and that's really the magic of containers. So anything you want to install within the container, that installation runs on your machine, right? Where you can test it, you can make sure that it's working inside the container before you then deploy that image to a server. Docker push, that publishes that container image that you built to a registry. Now, Docker Hub is a popular registry for public images. There are other options like Azure Container Registry, or you can even host your own private registry for your own images. Docker run is sort of a combination of commands. It downloads an image from the registry if it has not already been previously downloaded. It configures a container from that image and then starts the container. Now, notice a relationship between image and container. It's a lot like that of class and object. So a container is an instance of the image. Docker start, it starts an existing previously configured container that you had already ran Docker run on. Okay. Now, the obvious question at this point is, can you run VFP apps in containers? And the answer is yes. In fact, let's build one right now. And we're still talking about infrastructure as code, right? So the code in this case is a Docker file. And I'm going to walk through it. At the top here, we just have a command that changes the escape character from the default, which is a backslash, to a backtick. Now, we know that we use backslash all the time on Windows, right? So this is the first line you're going to see in many Windows Docker files. Docker containers are assembled in layers, and the structure is very similar to VFP's inheritance. And so in this container, our container is going to be built on top of the Windows 1809 layer, which corresponds to Windows Server 2019. Now, the next line copies the contents of the install folder from my local disk into the C drive install folder inside the container. So if I look at that folder, I can see it just has my Northwind setup, exe, okay? Lastly, we run that installer in silent mode. Here's our backtick. You can barely see it. But that's just a line continuation character in this case. And after the installation is complete, we just want to remove that install folder. We don't need it anymore. Okay, so I'm going to build this container now. No, that's good. Okay, so I'm going to say Docker build, and I'm going to name this image Northwind using the tag attribute. And then I'm just going to have a period here, which means perform the build using the Docker file that's in the current directory. And I could also have used a full path. Okay, so that's run now. Now we're going to run the image that I just built. And I'm going to use a -it, which means run it in interactive mode. And that's going to open a command prompt for us to use inside the container after it's run. And then I just have to tell it I want to run the Northwind image that I just built. And this takes a few seconds. Okay, so now I'm at the command prompt inside the container, and I can go to my Northwind folder, and you can see my application has been installed inside the container. Pretty easy. I mean, that's the basic formula for creating a container. I should mention one minor problem. This container is absolutely, completely, and utterly useless. That's because I've installed a desktop app inside the container, and containers are not for GUI applications. Sorry if I misled you on that, but the Windows graphical user interface is not supported in containers. So you won't be using containers to deploy FoxPro apps on the desktop. Containers are designed for console and server applications. Web apps, Windows services, background tasks, command line utilities, basically anything that doesn't need a graphical interface. Now we are going to look at a real world example in a minute. Before we move forward, I do want to announce a new project I've been working on called Fox Containers. Several pre-built VFP container images have been published on Docker Hub at the link you see here. So you could build your own containers on top of those, or you could just look at the Docker files for those in GitHub as examples of how you could build your own Docker files from scratch. And the images are available now on Docker Hub and the GitHub repository. Not yet, that's coming soon. So this includes a container image named VFP9 runtime. And as the name implies, the VFP9 runtime is pre-installed in the container. And it includes the VFP ODBC and OLADB drivers as well, in case those would be needed. VFP9 runtime IIS, this inherits from the VFP9 runtime container and adds IIS inside of that. And again, that could be used as an example of how you might get IIS in there inside the container for a web app. We also have one that has the full VFP9 IDE, and then one that inherits from the VFP9 container and adds Fox unit as a layer. Now, those last two are interesting. You could perform your CI/CD build inside a container, right? And then you wouldn't have to install VFP9 or Fox unit because those would already be installed inside the container. That sound pretty good? It is, but you're not going to want to run this on Microsoft's hosted servers, okay? That's because it takes about 20 minutes to download and extract the base Windows container image, and you would take that hit on every single build, okay? So if you want to use Microsoft's hosted servers, use the techniques I already showed you in the previous pipeline. But if you have your own build server, then yeah, it might be beneficial to containerize your build environment. And there's an example of this in the white paper in the downloads. 20 minutes to download. Why does it take so long to download the base Windows images? They're supposed to be lightweight, right? Well, there are a few things you should know about Windows containers. While Linux containers, super popular, super cool, Windows containers, not so much. And there are some reasons for that. To start with, Windows containers are huge. It's not that the Windows kernel is that much larger than Linux, but because of the way Windows is designed, it requires many files to be inside the container to support your applications. Linux, on the other hand, can reach through to the host OS for more things. Now, Microsoft has mitigated this to some extent by offering containers of different sizes, different capabilities. You can choose the smallest one that has what you need. But unfortunately, FoxPro requires the full Windows API, which is only available in the largest image. To add insult to injury, these files inside the container have to be compatible with the kernel of the host OS, meaning the version of Windows you run in the container has to match the version of Windows on the host. There's a workaround that helps with this. It isn't very attractive. So if you're targeting a specific version of Windows Server, you just got to deploy it on a specific server. No problem. You just build the image using that version of Windows. But if you want to have a container that supports multiple versions of Windows, you'll want to build multiple versions of your container. So if you go check out my Fox containers on Docker Hub, you're going to see that each one has multiple tags. So there's a VFP9 runtime for Windows Server 2022, another one for 2019, and other versions. So it's issues like this, yes, they chip away at the value of running containers on Windows. That said, the fundamental premise, the basic idea behind containers, it still holds true on Windows. So with over 1 million downloads on Docker Hub, you see some uptake of Windows containers, but it's not on the same level as Linux. So I've also built some containers for .NET to Fox on top of the base VFP images I've already shown you. And we're going to use that for one of those for our final example, deploying a fully functional web API inside a container. And so I'm going to go over to Visual Studio. And Visual Studio will actually provide a Docker file for you. And Microsoft took an interesting approach and put the build instructions inside a Docker file. So as a result, we do have a more complex multi-stage Docker file. I'm not going to walk through it. I just want to point out I only made one change to what Visual Studio provided. I replaced the ASP.NET 5.0 image that Microsoft provides with my own container that also includes ASP.NET 5.0, but has .NET to Fox installed with it as well. And .NET to Fox requires COM, it uses COM, so it requires COM registration, some DCOM configuration to use in a web environment, and that's already all been done inside the container, so one less thing to worry about when deploying. It also exposes port 80, the standard HTTP port, that's going to give us access to the API that's running inside the container. Okay, now since the build instructions are inside our container, inside the Docker file, our CI/CD pipeline, we still want to use one. It's actually very simple. So I just have two steps here, one to build the image from the Docker file, and another to, and that's continuous integration, another to push it up to Docker Hub. Very simple. And then to install this container on my server, I go over to the releases, and I look at the script here. I've got this one right inside of Azure DevOps. And I'm just deleting any existing container that might have been previously deployed to this server. I'm using Docker pull to pull the latest version of my container down. And then I'm using Docker run to run it. Now I want to point out a couple of parameters I've specified here. This -p says take port 80 from inside the container, and we saw that that was exposed, right? And map that over to port 3000 on the host. So I'll be able to access this container at port 3000. I also have a volume mapping here, which says map the C Northwind folder from my host system to that same location inside the container. Now, why do we do that? This is an important point. Never store data inside a container. Should always store your data outside the container and access it like this using volume mapping or maybe some other mechanism. Even with database servers like SQL Server, right? The database files themselves should be stored outside the container. Consider a container disposable. And if you delete it, any data inside of it would be lost. Okay, so I've already deployed this container to my, let me close this, to my VFF server. And here you can see it's running on port 3000. And I can just go over here and I want to look at pull employee number 1. Okay, and there's our result. So we've just ran a request inside our container and viewed it in the browser. There are some other, few other container tools you're going to run across. Running short on time, so if you want to learn about running multiple containers, check out Docker Compose or Kubernetes. So that's containers and infrastructure as code. Before we wrap up, I do want to show you just one more thing. Now, one problem you're going to run into with containers is that since it is console only, there's no GUI, right? You can't work with anything interactively in FoxPro. So if you do have trouble getting your stuff working inside a container, it can be really difficult to troubleshoot. So to help with that, I'm going to show you a second project I've been working on called Fox Console. So I'm going to hop over here to Docker Desktop. And this Northwind Web API is already running on my local machine. And Docker Desktop just gives me an easy way to open a terminal into that container. Okay. And so I can just, now that I'm inside it, I can type foxc. And I've got my FoxPro logo. I've got my classic dot prompt, set nostalgia to max. And of course, I have to do my hello world. And that works how you would expect. Let's see where we're at. And I want to go over to a data folder and work with some data. So I can, directory here, there's my list of tables. And I'm going to use categories. Shall we try to browse? Sorry, I'm not that good. We're still in a very simple console environment. But we can go old school. List works, right? And so if I want to see, this is a memo field. If I want to see the contents for confections here, I can first go to that record, print description. Okay, there's our contents. Let's see what else we've got. I want to run a query from the orders table, but I don't remember what the fields available are, so I'll list the structure here. That works. And I'll run a query. I want to see the top 10 customers by number of orders. So I'm going to run a query here. And if I typed it correctly, there we go. Queries work. Okay. And I can also list status. And I can see my work areas up here and some of my environment settings. What about variables? Yep, that works. Let's work with an object, some of our existing code. So I'm going to instantiate my employees object. And this code is inside my exe, so I have to tell it that. Then I'm going to get another object, employee. I want to get employee number 1. Okay, and that's going to return an object. And I just print that out. Well, that's not very useful, is it? But did you know that this command existed? There we go. There's the properties of our employee object. Now, what if you try to get in trouble? I'm gonna try to make a message box come up in a console environment. Well, Fox Console will try to keep you out of trouble where it can. It can't always do that. If you do get stuck, you can always just Control-C to break out of it. So I can quit, and that just takes me back to my Windows command prompt. What do you think? Kind of cool? Fox Console is already installed in all of the Fox containers, and it needs some more work before I bring it over to GitHub. Just about out of time, so I'm going to just close up. Here's what you learned today. Things that we talked about. Hopefully you have a better idea of what DevOps is and how you can use it with Visual FoxPro. Thank you for attending. If you do have any questions, I'll meet you in the Q&A room in a couple of minutes. fill out your evaluation, and that's it.